very excited. I am very excited because I believe in my heart that I've kind of unlocked the key or found the key that is going to allow you to do significantly better than the first two classes I had that took the Regents. I think that what I'm able to do for you is much more than what I was able to do for them because of my greater understanding of what to expect on that test. And part of the plan is these take-home quizzes. They are a very, very, very important part of what's going on. And it's extremely important to me that you be able to work together on these things. Please don't put them off till the last minute. Well, you worked with Aiden, so that's a good thing. I want you working with Aiden. I want you working with Jared. I want you guys sharing your work with Emily and with Ivy and everybody else in the room. I want it kind of spreading like good disease, okay? That good things are happening. Okay, now, let's get into the first one. I was so happy that almost every single person in the class got this right, which is really cool given the fact that on the last quiz in the beginning, nobody got it right. All right, Font, could you do me a favor, please? Do you know what I'm going to ask? Yep. Okay. Now, solve by completing the square. Whenever we do completing the square, and there's the key words that you would circle, what phrase pops into your head?
Square.
Half and square, right? Remember that half part because it affects number 4. X squared plus 10x is going to become x plus 5 squared. But I really needed a plus 25 there, so I really needed a plus 25 there. So that makes it 33. Then I square root both sides, and I get x plus 5, because the square root of something squared is that thing, equals, and here's the one thing you had to learn, plus or minus 33, not just radical 33. And then minus 5, and I get x equals negative 5 plus or minus radical 33. One or two of you put positive 5. That's just a sloppy mistake. I don't think that's a really big deal. Make sure we don't do that next time. Make sense?
Yeah.
We all good?
Yeah.
Right? You guys did a great job on that on the quiz. Now, I was extremely happy with number 2 because just about every person in the room realized that the coordinates of the vertex were 4, 7. Horizontal shift, vertical shift. The horizontal shift, remember it's always reversed, 4 to the right, that's positive 4. Vertical shift, 7, up 7. So 4, 7. We good? Now we get to the bad. This next question, or the next two questions, people tended to not completely miss, but somewhat miss. Oh, it was number 3, I'm sorry, that half and square is what you should have remembered. Yeah, oh, Lila completes the square. Key phrase. That means what?
Complete the square.
Half and square. So if that says X, I don't care about the B. What they just want to know what's the value of A. A is saying what's the guy that goes there? Half. What's half? Well, it's really going to be like x minus 6 squared, but the form is x minus a. So the minuses match, so therefore a has to be 6. No, because of this. If this said x plus a, then it would be negative 6. But they wrote x minus a, so therefore the x matches and the minus matches, so the a has to be the same exact thing. So the a is a 6. Okay?
Okay.
All right.
Okay.
Next, how many real solutions? How many people felt lost on this one?
Me. Oh, hello.
All right.
You were rushing me.
I am going to show you the light. Everybody say hallelujah.
You should give us a little
You stink. Say hallelujah. What if I guarantee you this is the easiest question on the quiz by far? Everybody say hallelujah. All right, say I. Oh, how lame is this? Do you see what I have to work with here? Right? Do you like go home and say, poor Mr. Linkless. He's got his work cut out for him today. Well, we're good. She's fine. Now, everybody get your calculator out. Graph it.
I was gonna do that.
Told you, this is the easiest question on the quiz. By far, not even close. That was, yes, you did. Now, you graph this guy, and I don't know, it looks something like this.
Yeah.
The real solutions are how many times it hits the x-axis. Remember we went over that yesterday from the homework? How many times does the graph you just graphed hit the x-axis? Un gas. 0. Now, That means the answer is 0.
I just justify it.
Now, justify it. Emma did a perfect job. She drew a picture. She said it doesn't touch the axis.
I know how to justify it. I just didn't because we were rushing.
Oh, that's it. Blame the mail.
I did.
Well, but I also said to you, I'm not worried about it because you either remember or you don't, and you're going to get the quiz back tomorrow. And who's going to miss this tomorrow? Well, you know what I mean, Monday. If you miss this, shame on you, okay? There's another way to do it that I want to bring to your attention. It's a little bit, it's very easy, but by the same token, it wouldn't have been my first way to do it if I was a kid taking a test. Remember in the quadratic formula, we talked about that discriminant?
I was doing that.
B squared minus 4ac. Well, b is negative 2, so I square that, I get 4. Minus 4 times 1 times 5 works out to negative 16. So I would have a negative 16 under the radical. Is it possible to find the square root of negative 16?
No.
No. Therefore, there are no real roots. Okay?
I want to do it that way.
Whatever floats your goats. Okay?
It's not slow.
They don't code either. Now, all right. So, now, hey, look in here. Look at here. Can everybody see that that really wasn't such a hard quiz?
Whatever.
Right? You guys are very distracted. Look here. Can you all see that that's not such a hard quiz?
Yes.
All right. Jaden, wake up. So I think if you go home and you just review it tonight, and then you review it Sunday night, I think when you take the quiz on Monday, you'll do very well. We had 100. We had a lot of 75s. A lot of people got 75. And then some 50s.
Go, Kirsten.
Okay? I felt great for
Not
Kirsten.
here right now.
All right. So
You go.
let's do some things here. We're going to talk about other kinds of graphs today, which means we're going to use our graphing calculator. What is x squared when x equals 7? 49. Good. What's the square root of x when x equals 81?
9.
What is x cubed when x equals 5?
125.
And what's the cube root of 27?
I don't know how to do it.
Okay, let's talk about how to do it on your calculator.
I could learn that. I tried everything.
Last year, but I don't know.
I am going to help you very much find it. There's two ways to do the cube root, but I'm going to show you a way that'll work for the 4th root, or the 5th root, or the 32nd root, or any other root in between.
Okay.
Now, first we're going to wait for them to check my software and see that I am legally allowed to use this particular program.
Okay.
It's like waiting for the Islanders to score a goal.
It's
Oh,
Why are you gonna sit? It's right there. It's open.
nice.
It's been open for like 20 seconds.
I had to tease Pringle. Okay, let's go. Second quit. Nice. Now, how do I find something like a cube root or a 4th root or a 5th root?
I don't
Let's
know.
go do a little bit of side work here. Square root. What power is the square root? Well, the square root is x to the 1/2 power.
Oh, so, okay.
What do you think the cube root is? X to the
third.
1/3. The roots always become reciprocals.
Okay.
What do you think the 4th root is?
X is 1/4.
X to the 1/4. What do you think the 32nd root is? X to the 1 over 32. So, if I want to find the cube root, I think the best way to do it, because it puts everything together, would be to, what did they want? The cube root 27?
Yeah.
27, up arrow, that means exponent, and then parenthesis, 1 divided by 3 parentheses.
Got third.
Enter. Great. Now the cube root means the number that times itself and then again used as a factor 3 times equals 27. And that's 3, because 3 times 3 times 3 is 27. Okay? Any questions? We all good? Okay. Now, graph y equals x squared and y equals the square root of x on the same axis. So, rather than do it on this set of axes here, let's just do it on our graphing calculator. Let's go to y equals, and then let's type in x squared, and for, clear, x squared And then for the second one, let's do the square root of x. So I'm going to go second square root x. We all got that on our calculators? Right? The first one is y equals x squared. The second one is y equals the square root of x. So this is a little bit of a different graph. We've touched on the square root graph earlier this year, but we haven't done a lot with it. Now, hit graph.
I hit it.
And there's my graph.
Oh, that's pretty.
Okay? So, here's what we should recognize so far. A graph that looks like this, what's that called? It's quadratic, but the shape is called a parabola. Now, the one that goes like this is going to be a square root curve. This is y equals x squared. This is y equals the square root of x. Okay? There's actually a reason for it. I'm going to show this to you, but I don't think you really have to remember this, but it's something that's coming in the future. There's a line y equals x that runs right up the middle of this. God bless. Y equals x has a slope of 1, God bless, and a y-intercept of 0, okay? Now, do you remember how last year you did these things called like reflections and rotations and dilations?
Yeah. I
Okay,
hated those.
the reflection means to flip. And last year, you did reflections over the x-axis and you did reflections over the y-axis. But it's possible to reflect over any line in the world. And one of the most famous lines to reflect over that you did not cover last year is y equals x. The reason that's so important is an inverse function. Is a function where you switch the domain and the range, which means you switch x and y. And that means you reflect over it. So doesn't it look like you took this part of the graph here and flipped it over?
Yes.
Okay, it looks like you folded it over on a diagonal, and this line would land on top of this, or that part of the problem would land on top. So that's really what you have going on there. You don't need to remember that. You will not be tested on that. But to me, it's a pretty cool little side fact. So far, there's two graphs we should know. We should know y equals x squared, and we should know y equals the square root of x. Now, do you remember what type of graph that was?
Exponential.
Exponential, very good. And that would look like this. Y equals some number to the x power. And I think we will get to that in just a minute. Okay, now, let's do x cubed and see what that graph looks like.
Okay.
So I'm going to clear this out, and I'm going to go to y equals.
Now here.
I'm going to clear it,
On top.
clear it. Let's only do x cubed. How do you think we could put x cubed into the graph?
X arrow.
That's right. X, up arrow, or caret is what it's really called. 3, and then let's hit graph. And there it is.
Huh?
And this,
Wait.
by the way, makes a lot of sense.
No.
No, it does. I'm going to explain to you why. Do you remember how if we had the graph of a parabola, which cube is kind of like squared, right? If we had the graph of a parabola, it would go this way and match up with this half, right? You with me on that? You with me on that? Now, what is -2 squared? Guys, pay attention. What's -2 squared? 4. So if I take a negative number and I square it, I get a positive number. What if I do -2 cubed? It goes back to negative. That's exactly right, which is why the graph, instead of going back up to positive, the graph does a little wiggle and goes down to negative. So, yeah, a little wiggle jiggle there right there. Okay. So, that makes sense that the cube root or the cube graph would look like that. So, in addition to all those little type forms, if you happen to be looking at a graph one day and you see a graph do this, what type of graph do you think that is? That's right. In there, it's something's cubed. Now, it maybe have horizontal and vertical shift, just like the other one. For instance, if I wanted to graph this, I could do the same exact thing we were doing yesterday. I could go 5 to the left, 1, 2, 3, 4, 5, down 1, and then just draw the same graph. Because it's that same exact idea of vertical and horizontal shift. In fact, every single point moves 5 to the left and down 1. I could go over here, 5 to the left, down 1. I could go over here, 5 to the left, down 1. Over here, 5 to the left, down 1. Every single point shifts 5 to the left, down 1 when I put it in vertex form. That's the great advantage of vertex form. It lets us visualize that. It's like doing a translation. You remember that from last year?
No.
reflection. Translation was when you added and subtracted and your horizontal and vertical movements. Okay. All right.
Nothing from last year.
Now,
I don't
the next one it wants is the cube root of x. So let's get to that. I'll go back to y equals, and then I will go down to here. Now, instead of, how do we put in a cube root again? How do I do cube root? Right, arrow to the 3, or caret symbol is really what we should be calling it. X, caret, and then make sure you use parentheses. 1 divided by 3. Otherwise, it interprets it differently. Okay? And graph. And can you see the flip over that line y equals x? You might even see it better this time. Right? Here's the line y equals x. Can you see how the graph is being flipped over that line? Or reflected over that line? Because you're switching the x and the y. Okay? Any questions? Today is all about recognizing graphs. That's all we really want you to be able to do from today's lesson. All right, so let's go with this. Ready? What kind of graph?
Cube.
X cubed. Good. What kind of graph? Square root, right? What kind of graph?
Cube, square
Hey,
root.
look. What kind of graph?
Square root, cube.
Cube root,
Cube root.
right? Let's see. We did square root. We did cube root. What was the other one we did? Well, I know we didn't do this, but what kind of graph is that? Exponential. We're going to do a ton of those in the next couple of days. There's one coming that looks like that. That's absolute value. So the whole point today is just to be able to look at the graph and say, oh, I know what kind of graph that is. And then, if you want to take it one step further, be able to understand that we didn't do too much with this today, but we will tomorrow. Vertical and horizontal shift works with every graph known to man. It doesn't just work with the parabola. Inside the parentheses, what do you have to remember to do with horizontal shift? Opposite, reverse it, right? If it says +5, where do you move? -5. If it says -5, you go +5. And then what about vertical shift? Same thing, stays the same all the way through. Okay, you may begin your homework.
I have a
Thanks,
question
John.
about this.
She has a question.
Just do, like,
Oh, in a week.
oh,
Take home quiz. Every Friday the take home quiz is going to be due. And I'll always give them to you from now because we've started them the week before.
because it's not an exam, I thought it was like the, like,
It's review for the final exam.
I thought it was the test of the quiz.
No,